So in the previous video, we have completed the estimation of missing data concept. So we have understood that for analysis of any data, so in our case the analysis of rainfall data, there has to be certain characteristics of data that has to be met. So the first characteristic is the data should be continuous, that is there should be no gap in the data. Okay. Second is the data should be consistent. The meaning of consistent means it is the previously whatever the data is there, let's say 10 years before, whatever the conditions of land and environment were there, the same condition should be there, or we have to make it consistent with the similar conditions of the land and environment which is present right now or after 35 years. Okay, so this comes under the topic of analysis of data and estimation of missing data. Okay, now the next concept that we are going to see is, after the measurement of precipitation and getting the particular data, what are the various presentations, or we can say how we can represent this data. For the studying of any data, there has to be certain presentation of the data. So the next concept is studying about this presentation only. So the rainfall data can be presented in the 5 different ways. Okay, so we are going to see the 5 different ways here. So give the heading presentation of rainfall data. Presentation of rainfall data. So in this, the first way in which we can present the data is mass curve. Okay, in the previous lectures we have gone through this word mass curve. Okay, so now we are going to see what is a mass curve. The second way of representation of data is the most important in this hydrology, that is hyetograph. Okay, so it is called as hyetograph. The second or the third one is moving averages. Moving averages. The fourth one is called as depth, area, duration curves. So in short form, it is called as DAD curves. The fifth method is intensity, duration, frequency curve. Intensity, duration, frequency curves. So in short form, it will be IDF curve. And the last one is a depth, duration, frequency curve. So depth, duration, frequency curve. So short form, it is DDF curve. So these are the 6 methods in which the data can be represented or it can be presented. Okay, so in this, the most important one is this hyetograph. Okay, so the main focus will be in this hyetograph concept only. The remaining one, or we can say the last 3 that are there, it is only we have to see how it is represented. Okay, so what is the format of DAD curves, IDF curves and DDF curves. So that is what we are going to see. And there is only one point in this moving averages that was asked once in an IAS exam. So that also we'll see. And the first one and the most basic representation is the representation of data in the form of mass curve. Okay, so let's start with the first heading, that is mass curve. Mass curve, also called as a rainfall mass curve. Okay, so write down the first point in this. So recording type of rain gauges, recording type of rain gauge, like, so there were 2 recording type of gauges which were directly giving us the mass curve. So which were those two rain gauges, which two type of recording rain gauges? So the first one was weighing bucket type. Weighing bucket type and siphon type. Siphon type. Okay, so these are the two types of gauges which directly give us the data, or they directly present the data in terms of mass curve. Now what is a mass curve? So that you should know. So if you plot on x-axis and y-axis, let's say on x-axis we are plotting the time, okay, and on y-axis we are plotting accumulated rainfall. Accumulated rainfall. So slowly as the time will increase, then the accumulated rainfall will also keep on increasing and this will get plotted. Okay, so this type of curve is called as mass curve. As you can see, as the time is increasing, the accumulated rainfall is also increasing. So this point you should remember from this mass curve, that it is a plot between accumulated rainfall versus time. Very important. Okay, so this can be asked in the exam. So it is a plot between what? Accumulated rainfall versus time. So this rainfall is measured in what quantity? So we are measuring it either in centimeter or we are measuring in mm, and time generally we are measuring in hours. I hope it is clear. Now after the mass curve, the next type of representation is hyetograph. So give the heading, second heading, that is hyetograph. Okay, so write down the first point. So it is a histogram. It is a histogram, or we can say a bar chart, a bar diagram. Bar diagram. So let's plot x-axis and y-axis. This is x-axis and this is y-axis. So these plots are very important. Okay, you should know what is on x-axis and what is on y-axis and what is the type of representation. So as we have written here, it is a bar diagram. Okay, so the values are represented in terms of bars. So you can see that these are the bars. Okay, so this is 1, 2, 5, 6 and so on. So here it is given in hours. This is time in hours. Okay, now on x-axis there is time which is given, and on y-axis the terminal or the terminology which is given here is intensity. Intensity I. Okay, now what is the meaning of intensity? That will write. First write down, this is a plot between intensity of rainfall, versus time. Okay, so what is the major difference between hyetograph and mass curve? The plot is accumulated rainfall versus time, and here it is intensity of rainfall versus time. So what is the meaning of intensity of rainfall? So intensity I, it is equal to precipitation divided by time. Okay, or we can say accumulated rainfall divided by time. Accumulated rainfall divided by time. So this accumulated rainfall can be either in centimeter or it can be in mm. So let's say it is in mm. So it will be mm divided by, if time is in hours, then hour. If it is given in centimeter, then centimeter per hour. So this is the unit of intensity. So intensity is measured in per hour or centimeter per hour. If in the example it is given that intensity is 10 per hour, intensity of rainfall is 10 per hour. What is the exact meaning of this? The meaning of this is in 1 hour. Okay, in 1 hour, what is the total amount of rainfall that is measured by rain gauge? 10 So if the rainfall is taking place for 1 hour, then the amount of water or the height of water which is collected in rain gauge is how much? It is equal to 10 So if you want to write down this condition in terms of intensity of rainfall, then you can write it as 10 per hour, because 10 is an accumulated rainfall and 1 hour is the time. So accumulated rainfall divided by time will give us the intensity. Okay, so this is the plot here, intensity versus time, I versus t. Now one of the most important part from the intensity versus time is, if you look at the units here, that is this intensity unit is per hour and this time unit is in hour. So if you multiply these two, that is per hour into hour, so you will get the value in That means if you calculate the area of this bar graphs, if you find out the area of the bar graphs, you will get the total amount of rainfall, because see, this is the rainfall intensity and this is time. So if we are multiplying these two, we'll get the rainfall intensity, and that is the next important point here. So write down total rainfall, total rainfall can be calculated, can be calculated using area of hyetograph. Very important points. Okay, so now we are getting to the crux of this hyetograph. So if you want to find out the total rainfall, how much is the total rainfall that is taking place, so what you have to find out? Area of hyetograph. Area of hyetograph will give us the total rainfall. Now if I want to find out the total rainfall in the first 2 hours, if I want to find out the total rainfall in first 2 hours, then I will have to take the area of the first bar graph and the second bar. So up to here only I will have to take. If I want to find out the total rainfall up to 6 hours, then I will have to find out the total area of this. How to find out the area? See, this height here, this height is the I value. So you can measure the I value from the diagram, and this is a rectangle. Okay, so we know the height, and this base is equal to 1 hour. Correct? So you can see the gap here is 1 hour. So length multiplied by breadth, you will get the value of area. So with this now you can calculate the total rainfall by using the hyetograph. So write down, this is the first one, total rainfall if you want to find out, and if you want to find out rainfall between some time interval. So let's say a rainfall between time interval ti and ti plus 1. So this will be equal to area between ti and ti plus 1. Okay, so these are all the important points from hyetograph. Now let's start with the next one. The next one is called as moving averages. Relatively easy. So if we are taking the average as we are getting the data, let's say that we have the last 5 years data, 1 2 3 4 and 5. Okay, so last 5 year data we have. Now we will be taking the average of 5 data. So this is our first value, this is the first reading. Now the value that we will get this year will be the sixth reading. So once we get the sixth value, then what we will do, we will calculate the average of the six values. So we are getting the average of six value. So you can see now the average here is increasing. Okay, so the average value is increasing here. We can also do one thing, that we can calculate the average of previous five values. So if I say that in this sequence find average of last 5 years. So first average will be, I'm giving the name A1. So first average will be average of the first 5 years, A1. Now in this year we have got the sixth reading. Okay, this year the reading is the sixth reading. So we will be taking the previous 5 years. So what are the previous 5 years? From here if we start 1, 2, 3, 4 and 5 up to here. So if we take the average of these two value, this will be called as A2. How to calculate this A1? Simple. So it will be 1 plus 2 plus 3 plus 4 plus 5, total 5 values divided by 5. Okay. So this is called as the moving average. If you find out the second point, it will be 2 plus 3 plus 4 plus 5 plus 6 divided by 5. So you can see we are taking the average of last 5 readings. Now if we plot a graph of this reading A1, A2 and if we just keep on going, then we will get a trend line here. We will get the value of trend line. So this is the time and this is the average. Okay. So what we will get? We will get the value of trend line. So there is an A1 here, then we'll get an A2, then let's say A3, then A4. So these are the points. So if we just connect this point with a smooth curve, a smooth line, let's say, then we will get the line here, and this is called as trend line. Trend line. Okay. So by seeing this trend line, you can see the rainfall is increasing or decreasing. So between A1 and A2, you can see the rainfall is increasing. Then between A2 and A3, it is flat. Then after A3 and A4, it has suddenly increased. Again from A4, it is going flat. So this is the use of moving averages. So from moving averages, there is only one important point that has to be written. So write it down. It helps in determining the trend of rainfall. This is again a previous year IAS question. So what is the use of moving averages? It is used for identification of trend. Okay, so let's go with the next one. After moving averages, we have DAD curves. So depth, area, duration curves. So from here now, the last three are relatively easy. We just have to draw the diagram and remember that diagram. So that is all that is required in this level. So these DAD curves are the representation of depth of rainfall, then area of rainfall, and then the curves which are required. So these are the two curves here. So first curve and the second curve. So this is the storm of duration T1 and this is the storm of duration T2. You should remember that this T2 is greater than T1. Okay. Now the next one is IDF curves, that is intensity, duration, frequency curve. IDF curves. Again, just remember this plot here. So the plot is between time, okay, then intensity I, and then we have the main curves. So these curves here if it is given T2, T3, so which of the following duration is more in this? So here the T3 is greater than T2 is greater than T1. So these are the depth, duration, frequency curves. Now the last one that we are going to see is DDF curves. So what is the representation of this? So what we are getting on x-axis and what is getting on y-axis, that is important here. So here it is the duration on x-axis and on y-axis it is depth of rainfall. Okay, and these curves are slightly different now. So you can see the shape is different than the IDF curves and DAD curves. So here the T1, T2 and T3. Here also the T3 is greater than T2 is greater than T1. See, these questions are not much asked in the exams and this part is not much important, but only thing you have to remember is once we have the data, let's say that depth of rainfall, duration of rainfall, then these plots can be prepared for the presentation of data. But as we have already seen that one of the best methods for expressing the data is hyetograph. So we can easily get the required information by using the hyetograph. So in most of the cases this hyetograph is only used and the most questions also are asked on this only. But let's say if there is some question which is asked from this part, then the important points are from the diagram base only. That the DAD curves are plot between what? So it is a plot between depth of rainfall and area. Second, IDF curves is a plot between intensity of rainfall and time. Similarly, DDF is a plot between depth of rainfall and duration. Other than this, if there is a question, then there can be a graphical question like which of the following curves are IDF curves or DDF curves. So by looking at the curves, you should be able to tell whether it is an IDF or DAD curves. So these DAD curves and IDF curves, these both are same. Okay, whereas the DDF curves are somewhat different than these both two. So you remember these 3 points, and with this we have completed the presentation of rainfall data part completely. Okay, so most of the questions will be there from this only. I have almost covered all the important points from this presentation of rainfall data.